Yep, it's ready.
And I'll share my screen. Okay. So can you see that?
Yep.
Okay. All right. So just speaking of process, we've in the last couple of sessions we've talked about equipment schedules, and then we talked about workshop drawings. At the moment, I can't see you guys, so I'm going to try and see if I can find you. That's better. Okay. So it's, as I keep saying, you know, all the work we do is a process. So we've got to follow this process, and then things usually work out pretty well. If we get messed up on the path, we can lose time, put it that way, because we haven't followed the system. So once we've got the electrical schedules, we've issued it to the drafting and to other people, the suppliers and so on, who need that information. The workshop drawings can commence, and now we can get onto the electrical part of it. So looking at the text here, all HVAC systems require power and controls in order to function and produce the desired environment. And the power is normally 240 volts or single phase, or 415 volts, which is three phase. Now, I think you're both familiar with those terms. You can jump in any time if you want to ask a question on these things. The wiring to the control systems is normally 24 volts AC. So that's low voltage, not dangerous. Obviously, 240 volts and 415 volts is dangerous. So don't touch. Okay? Treat with respect. 24 volts AC, well, it's not dangerous, but don't touch it anyway. The HVAC equipment is normally wired from one or more mechanical services switchboards, which we call MSSBs, and I'm sure you've seen that term. So there's a lot of jargon in what we do, so it's just identifying all these things and knowing what they are. The MSSBs are usually located as close to the equipment as possible to minimise the amount of wiring required. So that just makes sense. That's the closer the switchboards are to the equipment, the less wiring, lower cost, less voltage drop, because wiring has a voltage drop. So try and get it as close as you can. If the equipment is located in a plant room, the switchboard would normally be located in the plant room as well. That makes sense. There are some requirements around, or clearances around switchboards. This is in an Australian standard. AS3000 is the electrical standard. We don't really use it very much, but it's good to know that it exists. The electricians and electrical engineers use that standard more than we do, but we need to know that there are some requirements. Be aware that around switchboards there are clearance requirements for safety. So you can't put a switchboard in a space where you're sort of stuck there. If something goes wrong and you need to get away, you need to have clearances so that you can escape. Okay? For instance, if you get electrocuted, well, it's not, we don't want that to happen, but it can happen. Normally, as engineers, we don't stick our hands in switchboards, but tradesmen do, and they need to be able to escape if they get into trouble. Just keep that in mind. The submains coming into the switchboard are normally three-phase due to the large electrical loads involved. So they bring in three-phase power to the switchboard and then distribute it out to the equipment from there. The switchboards are normally wired from a project main switchboard, which is called an MSB. So just be careful of that distinction. So this is, the MSB is supplied by the electrical services contractor. It's not mechanical, it's the electrical contractor. Wiring from the MSB to the MSSBs is called submains and is carried out by the electrical subcontractor, not the mechanical contractor. So he brings all these wires, the electrical contractor brings all the wires to the mechanical board and leaves them in a bundle. and then the mechanical contractor terminates all those wires into the mechanical switchboard, and then installs all the wiring to the field, all the field wiring to the HVAC equipment. The mechanical subcontractor employs another subcontractor who does the electrical work. So normally the mechanical contractor, who is normally your client, doesn't actually do the wiring themselves. They get another subcontractor, and in the industry we usually call it the mech-elect contractor, because he's the mechanical electrical subcontractor. That makes sense? So that's another term you'll hear, the mech-elect contractor. He works for the mechanical subcontractor. So he goes ahead and installs all the field wiring to the equipment. When designing the wiring system, our job is to aim to balance the loads on each phase. The electrician will do this also, but we try and help them by trying to get a balance. And by that I mean, we've got three-phase power coming in. Some of the circuits are single phase and some are three-phase. So some of the bigger motors on air conditioning equipment or fans might be three-phase, and some of the small ones might be single phase. So where you've got a whole lot of electrical loads, you try and share the three phases between. If it's a three-phase motor, then that's fine. It doesn't need to be balanced. But if it's single phase, you try and select the phases that you connect it to, so that overall you get pretty close to a balance on the three phases. Does that make sense?
Yeah.
Because that's what the Electrical Supply Authority wants us to do as well. They don't want to give you a three-phase power and find that you've taken all the power off one phase, because you're going to overload that circuit and something's going to fail. Okay, so we try and balance it out so that instead of having 100 amps on one phase, we've got 30 amps on each phase or something like that. Okay.
So question, when we select our equipment, we usually find information about the phase, single phase or three phase. When it says that it's a single phase, does that mean that there's a single wire to be connected to this equipment? And if it is a three, then it's a three wires. And the next question is, why is single phase more expensive?
Hang on, I'll just answer your first question.
All right.
Single phase is, there's an active and a neutral. So the active is the power, and the neutral is the return line, if you like. So you'll have two wires for single phase. For three phase, you'll have four wires. So you'll have three active lines and one neutral. Okay.
Okay.
What was the second question?
Why is the single phase more expensive?
Single phase motors, do you mean, or?
Yeah. Are they more expensive than the three phase, or the wiring process for the single phase, is it more expensive?
Well, single phase equipment and wiring generally would be cheaper, but because in a project we've got a lot of power requirement, we have to have three phase to be able to get the power into the project. We can't do it with single phase.
All right.
The electricity supply authorities will not let you do it. You can't do it.
Mm-hmm.
And the bigger motors, when you're talking about pumps and chillers and all these things, the bigger equipment, it's always three phase. So we haven't got to that yet. The projects that you're working on don't have that big equipment, but some of the condensing units that you're dealing with and some fans will be three phase. So we'll talk about that more later on. In some projects you won't have a switchboard, and a lot of the projects you're working on probably don't have a mechanical switchboard, MSSB. So say on a project that has mostly just DX packaged equipment or split systems, they may be single phase or three phase, but the power supply will be brought directly to the condensing unit. so there's no switchboard. I'm sure you've seen these projects where there isn't a switchboard. So that's another situation that can occur. So when we've prepared the equipment schedules, we need to prepare a schedule of electrical loads. Now, I don't know, John, and you probably haven't done this, but you may have, and I know we're going to talk about that later this morning. So I'll just bring up some schedules. Can you see that spreadsheet?
Yeah.
Yeah.
I'll go to this one. These are on your standard schedule forms. I don't know whether you've been involved in filling one of these in yet. Have you done one of these, Stuart?
Old tabs were used. Mainly I worked on fans and VRV.
Yeah. So part of the
Soon
job
I'll
that
be
we
working on chillers.
okay. Part of the job that we need to do for the mechanical electrical subcontractor is to give him a schedule of all the electrical loads. I know that some companies in the past, well, probably still do, some smaller companies will just give the mech elect subcontractor all of the tech data for all the equipment and tell him to go and work it out. Well, that's not really fair. I think we need to take responsibility and tell him which switchboard the equipment is wired from and what the relevant loads are. So you can see on this schedule here, can you see my cursor moving around?
Yeah.
Yeah.
So down on the left column, this is where you would list what the equipment is. And there's another rough one here that I'll just open this up. So it's a list of the equipment down this side. And then the reference, which is, this is what the equipment is called. So the chiller 1, chiller 2, chiller 3, etc. List that equipment down. You can put a description here of what it is. Chiller 1, chiller 2, fan 1, fan 2, whatever it may be. This is power. This is the motor power. Okay. So it might be 1 kilowatt, might be 10 kilowatt or 11 kilowatts. It might be half a kilowatt. Whatever it is, put that down. And then the amps, the full load amps, which is you get from your selections from the equipment manufacturer's data. How many amps that draws. We really need to have another column that says whether it's single phase or 3-phase. Okay. So this schedule, I'm not sure whether you're using this. This is different to the one that I've used before, but you might check with. Now, if it's single phase and it's half an amp, voltage, stop. I've jumped ahead of myself here. This is voltage and phase. Okay. So this is where you put down, if it's single phase, it's 240 volts, single phase. Okay. Or 415 volts, 3-phase. And then speed control, does it have a VSD? If it does, you put in here VSD. Okay. Single phase loads do not normally have a VSD. They might have a like a potentiometer speed control, but so you can put that there. You can put pot or something, which is just a dial that you can turn to change the voltage and change the speed. But if it's a VSD, that would normally apply to a 3-phase motor. And the power type, now we've got down the bottom here, there's a description of different types of power. Non-essential means no generator backup. Okay. And usually these that would be abbreviated to NE. Okay. So you'd put up there NE, not essential, no generator. Essential has a generator backup. So these are things that you want to keep running all the time. It might be a special sort of exhaust fan, or it might be a laboratory that you need to keep conditioned at all times. And obviously, this only works if the project has a generator. Large projects with essential loads will normally have to have a generator, because otherwise, if you lose power, everything's going to fail. Okay. So that's normally abbreviated as ESS. So you've got NE, ESS, then you've got FE, fire essential. This is in a project where you have fire or smoke hazard management and smoke exhaust fans, depressurization fans, that sort of thing, that have to keep running in a fire. They have to be wired from a fire essential supply, which is fire-rated cable and generator backup. Okay, so just bear that in mind. The projects you're working on at the moment, I think generally will be non-essential, but if you've got stair pressurization fans on a project, then you're getting into the fire essential area. So you could put a lot more information in this spreadsheet, the location. One thing that I haven't noticed here is the actual name of the switchboard. You need to label each spreadsheet with the switchboard number, whether it's MSSB 1, 2, etc., so the electrician knows which one he's dealing with. Location of the switchboard, which area it serves, segregation. This is another thing that would normally be in the specifications for the project, but you may be required to work it out sometimes. Switchboards have forms, what they call forms, could be form 1, 2, 3. The higher you go with numbers, the more segregation is required. So, for instance, a form 3, now I'm going from memory now, so don't quote me, but form 3B might be or form 4 is a switchboard. I don't know whether you've ever seen them, but for each drive, for each fan or air conditioning unit, whatever it may be, air handling unit, is in a separate compartment within the switchboard. So normally the switchboards you're dealing with, if you open up the doors, everything's there in front of you. All the circuit breakers, switches, controls, etc., are all there. But on a form 3 board, they might be in separate compartments. So you can pull out each compartment separately to get to the wiring and controls just for that drive. That's a bit above what the level that we're working with at the moment. So don't worry about it, but just be aware of it. So that's what that is, segregation fault level. Have you heard that term? Okay, well,
Can you repeat the segregation thing, please? Can you repeat segregation? What does it mean exactly?
Well, it means segregation is another word for separation. So it's divisions between the different, what we call drives. Each electrical load or like motor, we call a drive. Okay. So if the segregation refers to the separation between that drive and another drive. So in a form 1 switchboard, you have no segregation. Okay, they're all in there together. But as you go up in the form numbers, you may be required to provide complete segregation between individual drives. Mm-hmm. We're now talking about extremely expensive switchboards. But in some projects, like in a mining job, for instance, or the standards, or your client might say, look, I want to segregate all the drives, because the reason is if a motor fails, let's say a motor overloads and the switchgear and the switchboard starts to burn, it starts a fire, they don't want that fire to spread through the switchboard. So you might lose a pump or a big fan or something, but if they're segregated, it doesn't affect anything else. Okay, but in a form 1 board where there's no segregation, if a fire starts in part of this because something's overloaded, a motor's drawing too much current, it gets very hot, a fire starts in the switchboard, you lose the whole switchboard.
Yeah.
Okay, but if it's a form 3, you only lose that part that started the fire. So it's just an extra safety. But sometimes it's a requirement. You have to do it. But not in the projects we're dealing with here at the moment.
Got it.
So
fault level. Sorry, John.
So do switch pods not have fused connections? Or...
Yeah, they do. Yeah.
Okay, but there's still a chance that there might be a fire. Or
there's always a chance of that.
Yeah,
You might get a short circuit in a contactor or something, and it gets too hot, starts to burn. Things can happen. I mean, with electrical systems, you've got to be ultra safe.
Yeah.
So even though there might be safety switches and circuit breakers and things, sometimes they don't work. The other thing that can happen is, I won't try to go through contactors in detail at the moment, but a contactor is basically like a circuit breaker that's connected to the controls as well. So the controls put a signal into the contactor, it closes the contactor, and the fan starts, something like that, okay? Sometimes a contactor can get very hot, and the contacts can actually stick and weld in. They can actually weld, so that even though the controls are telling it to turn off, it can't turn off because it's stuck together, okay? And it can get very hot, and then fires can start. So these things can happen, but we try to have enough safety so that it doesn't, but things still happen sometimes. Fault level is something that the electrical subcontractor has to deal with. It's not something that we normally worry about, but it will also always appear on switchboard drawings. And there's a definition of it, which is, I can send you this if you like. That's the definition. The fault level at any given point of the electrical power supply network is the maximum current that would flow in case of a short circuit fault. The electricians need to know this to work out their wiring system. They may ask you for the, well, normally they wouldn't ask you for the fault level, but you can calculate it. If you can Google it, there's a spreadsheet for calculating the fault level, but normally they wouldn't ask us to do that. So back to here, where were we? We're on the spreadsheet. So, okay, what else can I tell you? Okay, other information there. We can fill these lines in if we know, but these things the electrical contractor will know from the project documents what he has to do. So there's another, just while we're talking about this, there's a checklist here, and Bill and I think, are going to talk about this after. When you
That's for the good food.
Yes.
Yeah.
So this came in just at the right time, because this is very topical, and there's also drawings on this project that I've had a look at already, and we'll talk about later. But when you're looking at, there's a whole series of these checklists that Philip and I have put together to help you when you're checking things. Okay. So if you get you've issued your electrical schedules to the contractor, and the contractor has produced the drawings, and now we've got to check the drawings and make sure that that's what we need. Okay. Takes a little while to understand electrical drawings, because there's control circuits and there's relays and things. But once you understand how it works and how things are meant to work together, it's quite easy to follow. But at first, you need a bit of practice. But this checklist just gets you to go through and make sure that initially is all the required equipment shown on the drawing. Sometimes you might find that they give you a drawing that missed out some fans. And this is where the electrical schedule helps him tick everything off. So if you've got everything on the electrical schedule that you need to come from a particular switchboard, then he's got no excuse to leave it off. If he misses it, he or she misses it, then you can say, look, you've missed a fan, you need to put that on. Okay. Are all motor ratings in kilowatts and phases correct? Okay, so on their drawings, they'll show you the rating of the motor and whether it's single phase or three phase. So that's all very self-explanatory, but it just gives you a guide to work through the drawings. Is the full load current of each motor correct? You've put that on your schedule. The contractor may get it wrong when they do their drawings. They're only human, like all the rest of us. They can make mistakes. And if it's a, let's say it's a three-phase motor and it's 10 amps, 10 amps per phase, and they get it wrong. They put down it's a single-phase motor and it's 10 amps. Okay, they've made a mistake. That will affect the whole wiring of that circuit to the switchboard. So it's our job to just check that everything is correct. Okay, it's not hard to do, and people do make mistakes. Is the fault level correct? Okay, they will nominate a fault level. We may not know what it should be, but if we've been given a design drawing or there's something in the specification that says what the fault level should be, then that's what it should be. And so on. So we can go through all that, but it's all pretty self-explanatory. This one here, is a fire alarm relay required and included? If it's required, is it included? So the fire alarm relay is there to turn everything off if there's a fire alarm. Or that's one option. The other option might be to start turning some other things on. So if there's a fire in the building, it might need to turn on smoke exhaust fans, step pressurization fans, and that will all be included in the wiring diagram to show how that works. So if the fire alarm, usually the fire alarm relay is energized from the fire indicator panel, which is not part of mechanical, it's fire work, but they will send a signal to the fire alarm relay, which then causes things to happen in the mechanical systems. Indication lights on the drawings that I'm going to talk to with Dua about. We can have a quick look at those before we go if you like. It does have indicator lights to show that it's usually red or green. Red means it's not running. Green means it is. These days, you don't see as many indicator lights as you used to because a lot of things now are controlled through a building monitoring system. But if you go to a switchboard and you see a red light, you think, uh-oh, something's happened here. Should that be running or not? If everything should be running and you see a whole lot of red lights, something's gone wrong. So it's a quick indication that there might be a problem. Is the construction correct? This is the segregation we were talking about before. So is it Form 2, Form 3? What's it required to be? Make sure that they've got the right construction, and that will be noted on the drawings. Here's one that comes up sometimes. Is the colour correct? Usually they're orange, but that for the project might say we want white switchboards. Okay, so if they want white, they can have white. There's no real requirement as to what it has to be. Spare capacity. Sometimes they want spare capacity to add things later that they don't know about yet. They might want a 10% capacity, 20% capacity. So you just need space in the switchboard and on the wiring, they call it not carcass, but can't think of the word. Anyway, just extra space in case you need it. Is the switchboard floor mounted or wall mounted? Usually they're floor mounted, but smaller ones might just go on a wall. And that should be noted on the drawings. Is a GPO required and provided? A GPO is just a power outlet, single phase power outlet, which can be very useful for, so you can plug in a power tool if you've got work to do in that area. But if it's not asked for, you're probably not going to get it. But it's a good idea to have one. So I think that's probably, let's just go back to Yeah. When the wiring diagrams are complete and approved, the electrician can commence to manufacture the switchboards and install the wiring to the HVAC equipment. So this is the process that we have to go through. Check the drawings. They may have to be submitted further on. We would check them first and then submit them back. In your case, they'll go back to the mechanical contractor. He may then have to submit them into the system, and he probably will, like all other drawings, have to go into the system. So they go to the builder sends them on to the checking consultant, and then they come back. They might have comments, they might come back approved as they are, and then the electrician can start doing his work.
Oh.
So it's all a process. Any questions on that?
All good, but where do we normally find these information? Is it on the electrical schedules and the specs, on their drawings, on our drawings? Because on our drawings, all I could see is the location of the MSSP. And in some advanced, let's call them this way, mechanical schedules, you can find a reference that this equipment is connected to this MSSP, etc. But how about the whole list of the checklist? Where do we find this? Do we dig ourselves into the electrical works? What do we do?
Sorry, where do you find the checklist, did you say?
Where do I find the information to follow the checklist?
Okay, so this there's probably not a really simple answer to that, but look, in a perfect job, and we don't get too many perfect jobs, it should be set out in the specifications. Okay. If you have a specification, they should have an electrical schedule of some description that tells you what the switchboards are, where they are, and what they want, what equipment they want connected to those switchboards.
All right.
There'll be, if there is a specification. Now, we're talking about a project that's had some level of design done by somebody else, which is often the case, but not always the case, because sometimes you might have a construct project where it's up to you to make those decisions. It's really the only point that you're going to find it.
Yeah.
Okay. And if they give you drawings and specifications, they might indicate switchboards on the drawings and then describe it more in the specification. There'll also be, in the specification, there'll be an electrical section which sets out their quality requirements for the switchboards and for the wiring. And so you don't really need to read that in detail, but the mech-elect contractor does. He needs to comply with that. And really it's our job to make sure that he does comply with that. That he doesn't go off and do something that he thinks he'd like to do because it's cheaper or whatever, it's easier. He's got to comply with what's required. But in a design and construct, then you've got more freedom to do it your way. And then you'll have to decide what switchboards you want, where, what's connected to them, and all those things. Okay.
Yes.
So next time we'll go on to talk about controls. Each of these subjects is big. You know, we talk about it in half an hour. You could talk about it for a couple of days, you know, and you still be asking questions. So we are doing this very quickly, but I'm just trying to give you a bit of awareness to it because there's so many things that you need to be aware of. Over time, you'll ask questions, you'll get involved in projects and you'll understand how it works. But always ask questions. You know, we're here to help, and there's a lot to learn. You understand that? So we don't expect that you know everything. We're working as a team. Just ask the questions and we'll help each other get through it because that's what it's all about. And next time we'll talk about controls, which again is a short section of a very big subject. So, but just there's so many different ways it can be done. and we can just talk over the top. And as you go along, you'll get more and more into the detail of different types of systems. Okay, so that's probably it for now. Thank you. As usual, gentlemen, could you save that, please?
Yeah, no worries.
Any questions before we go?
Can we continue our call, you and I, to discuss the MSSP project?